All right, so hi everyone. Thanks for the intro. So I'm Arnault Ioualalen. I'm the CEO and co-founder of Numalis, a company working on AI reliability. But I'm also an expert in standardization in several standardization committee. And what I'm trying to do today is to give you some indication on how standards can help you adopt, even in critical industries, AI systems. Because we're not all equal under the AI adoption. In many sectors, adopting AI is rather easy. Like maybe in HR, you can use some LLMs to do stuff. But when you go to more critical applications, like in defense, like aeronautic, or like in automotive, or in healthcare, suddenly you have already existing regulation. You have existing certification, standards, you have a framework already in place that tells you how to build a system. And usually it's all about risk mitigation. Like if you're building like a plane, you're not allowed to have like 99% accuracy. We wouldn't even tolerate like 1% of planes crashing down. Like we want all the plane to fly. And so here we see that the classical methods to build systems will not really apply to AI system, because what we have right now is not always up to the challenge. And so how do we build an AI system right now? So what we do is basically we apply this kind of funnel. So it's a very simplistic way to put it, but it's what is written right now in the standards. So basically, you try to write some requirements. So what are you going to build? Then you try to bring up a lot of data. And you hope that your data is correct, it's various, it has right annotation, etc. And then you start training on some models you have chosen, or you maybe have designed it yourself. Then you go to validation, and so here you try to benchmark as much as you can in order to have like the proper safety requirements matched. And then you deploy and you monitor all of it. And it seems easy enough like that, but none of these steps is actually easy. And most of these steps are almost impossible to do in some cases. And so let's delve down, for example, on how we build safety critical applications right now. So if you come from the aeronautic sector, you're very familiar with this kind of V-cycle that is used to make safety critical applications. And so when you start with a need, then you go to a specification, some high-level requirements, and then you grind down into low-level requirements, and then you arrive at coding. And coding is just a way to answer the exact low-level requirements that you have received, and nothing more. You have to guarantee that you're doing exactly what you're being asked to do, and nothing more. And then you have the other branch where you're going to make testing more and more at the unit testing and then at the system level. When you're doing AI using the previous funnel I showed you, basically you're taking a shortcut. Basically you're saying, I have a need, I'm going to bring some data in, and then I will have my code ready. And you completely forgot all of the rest. Like, where are the specifications? Where are the high-level requirements? Where are the low-level requirements? How am I going to test it? Because I haven't wrote it. Because with AI, I have this illusion that I can just brute force my problem with more data and a bigger model. And that's the point that is stressing out a lot of the industries that are used to make safety-critical applications, because they don't work like that. They don't understand that. And they don't want to work like that, basically because they deem it unsafe. And it's not entirely irrational to have this fear, because we've seen it, for example, in transportation, in the automotive. The US is far advanced and have already like self-driving cars. However, many of the authorization they received are being rescinded, because they say, well, we let you try it out on the roads. We've seen how many accidents you caused, how many problems you're causing. You're not safe enough. So they are actually starting to see that we cannot just brute force the problem. We have to find a clearer and a smarter solutions. And so when a problem arises, usually there are some lawyers that are coming in. And when lawyers are here, usually also the governments. And so right now, there are plenty of regulation that's brewing. Previous speaker was speaking about that. Obviously, there is the EU AI Act. I think most of you have already heard it already today. But it's not enough. It's not the only one. You have, for example, even in defense, NATO is building its own reference for certifying AI system. So it will be regulation for the military. And you have several countries that are doing their own small version of the AI Act in their own. And so you have UK, you have Canada, you have Singapore, you have South Korea, you have Japan, you have even the Philippines. We discovered that last month. The Philippines are building a regulation on their own, and they're going to enforce it for all AI applications. And so, as an industry practitioner, how am I going to deal with all of that? Because if every country has its own and everything is different, how am I going to export my product? If I'm in Serbia, I want my product to maybe go to China, to go to the EU, to go to the US, and I don't want to have like completely widely different regulations to abide. So how am I going to do that? So usually the answer is here is through standardization, because the regulators, let's be honest, they're maybe in good faith. They're trying to build something that is, meaningful in order to protect their citizens. But they're not technicians. They're not AI engineers. So they don't know actually what to do in order to make an AI safe. And so in the EU, basically, what they said is that they have this new way of building regulation, which is called the new legislative framework, which is say, basically, I'm going to write requirements that are unclear, but for me, they're enough. And then I'm going to ask some standardization committee to write the standards to match these requirements, and basically shift the problem to them and say to them, well, deal with it, bring me some standards that I can use in order to abide to my own regulation. And so this is what happened for the EU AI Act. They basically said to the Senelec, hey, guys, please do us this favor and build the standards we need. But the two worlds are not exactly aligned. Obviously, the EU AI Act is using terms, very general terms, like, yeah, I want AI to be robust, secure, it needs to have some oversight, without defining any of those. And on the other side, we have standardization committee that are talking about technical stuff. So stuff like, yeah, you can have like a metric like the F1 score to measure accuracy, you can measure stability, you have like gradient attacks, etc. So very, very narrow technical stuff. So we need the two to communicate in order to make it work. And that's the point actually we're doing in the standardization committee. We are trying in these whole architectures of how to comply to regulation, how to build with different standards and different standardization committee frameworks that are answering that. And they are back and forth between regulation, between standards, between the industry, because we want the standards even to be applicable to the industry. Otherwise, it's meaningful. It's not meaningful. And so we're part of this, the MALIS. Basically, we wrote most of the requirements for robustness in the ISO and in the Senelec, and we're trying with the Commission to align with them what they're expecting to have in terms of compliance with the regulation. And so this whole play here is done currently and should be arriving at some form of deliverable in 2025. Let's be hopeful. And basically, it's a huge investment of effort. We have many, many, many standards that are coming. So right now, the most advanced standardization committee available is the ISO. It's been founded 6 years ago. It has already have like 30 published standards. We have 36 ongoing one, and we're already talking about like adding at least 20 more. So it means like in a few years you will have like probably almost 100 standards available from the ISO. Which one would be applicable for the AI Act, well, that's at the Sensenelec level to decide, which is also building its own standards. So the previous speaker was right. Regulation is moving fast, standardization is also moving fast, and we need to be agile because you will have tons of documents to read and to integrate into your own governance in order to make it work. And since AI is an ever-evolving field, this is probably going to be a trend. This is not just a phase. Because in 2 years, if, I don't know, some new ID comes up, like generative AI 3 years ago, we'll have to deal with it. We'll have to adapt regulation, we'll have to adapt all the standards. And so you will have to adapt your own governance. And so the processes, the tools, everything will be adapted in order to cope with this new AI development. However, right now, basically the framework in order to make an AI compliance to the regulation of the EU will look like this, approximately. It's basically something that will deal with 5 major standards. Obviously, you'll have a management system, so something at the top, really for the organization to say, I am proficient in AI and have the right structure. It's not talking about product, just about your own organization. One step below, you'll have risk management. How do I evaluate the risk of my own systems? And how do I cope with that? What organizational steps did I took in order to make it work? Conformity assessment, because, hey, you need to be certified at some point. Basically, regulation will ask you at some point to be certified by somebody else. Self-certification, probably not a good thing for AI, because there is a lot of bias when you build AI, usually when you're on data. So probably a third party will be necessary. And finally, you have the low level regarding the product. And here we're really talking about AI quality, AI trustworthiness. And so here you will find the actual requirements regarding how to build the product, how to verify the product, and how to deploy the product. Otherwise, you will not be able to comply to the upper level. These can change, definitely. But for the next 2 or 3 years, we're hopeful this will be the architecture that the EU will propose, and which would be probably inspiring other countries. We have several countries, for example, Japan or Korea or Canada, that are coming to EU at each of our meetings in Sensenelec in order to see how we do it. Because the EU is the most advanced in terms of regulation right now. So everyone is like copying what the neighbor is doing. Because, hey, why not? It's free. So let's show you now how one requirement is grind down until you have like something actionable for an AI engineer. So here I've chosen robustness because, well, that's my main expertise I have. And so in the EU AI Act, it's basically one article that says the AI should be robust, accurate, and cyber secure. So it's wide open there. You have like 3 completely different things, and it's all in one article. So it doesn't tell you at all how to do any of that. So to answer that, the trustworthiness framework, so remember the one at the bottom, is trying to define 14 requirements. So from one article, we end up with 14. And in these 14 requirements, we describe a lot of stuff. We say, well, we need some definition of an operational design domain. So where are you going to use your system? We are defining what kind of events can happen in your domain of use. And at some point, we thought that, well, it's too complex. So what can we do? We don't have time to write all of it. And so what we've done, we said, well, there is some ISO document already published. We can just say, hey, use that, so that we don't have to work anymore. And so we gain time. And so basically, the last requirement is telling you, well, please do use ISO 2429 so that you can implement robustness. All right, so I'm an engineer. I'm follow up the trail. Okay, so from ISO 2429, so I'm going now into ISO world. And so in this document, now I found metrics, I found concepts that are actually actionable. I can implement them. There are formulas, there are, notion of thresholds, stuff that an engineer can write it down in terms of specification and then verify it. And remember the V cycle, all the V, the left part of the V where I don't have specification, high-level requirements, low-level requirements. Now I kind of have. Now I can express something that is finally grinding down until we have specific requirements to verify. But one major catch here is always the notion of domain. Where are you going to use your AI? And here we touch something that is quite hard to explain because AI is basically a tool that is very good at catching the behavior of a system on an unknown domain. If you were to know exactly what domain you're going to use and how it operates, you wouldn't use AI. You will do classical software because, hey, you know exactly how it does, so you can formally describe it. You use AI on stuff you don't understand, on stuff that is too complex to model. And so when I say, yeah, you have to have a given domain, well, I'm putting you in a conundrum. How are you going to have a defined domain in an application where you don't know the domain? And so here we're starting to have like a new approach needed. So what we propose in 2429 is, for example, to describe the domain as a set of attributes that can vary. Like if I had this domain of, yeah, I want to detect tanks. Here is a tank, but in my domain, there is a lot of that can happen. So it can be, foggy. It can be, my lens is dirty, or it can be perturbated by the lightning. And so all of which is changing the notion of the domain I have described before. And so what I need is a way to model all of that in order to verify over the domain that everything is fine. And if my system is telling me, this is a tank, it should also tell me that these three are tanks. And so I want to verify that. But I cannot just, randomly pick every variation. There are so many, like almost an infinite number. So I need to find a way to model all of that and verify it at once. Otherwise, it's too long. And so this is what we describe, and this is what our company does, actually. So we allow to model, the perturbation space. What can vary in my domain once I express it? And then through tools, we can analyze how this domain evolves inside the neural network, for example, if you're using neural networks. And you want to verify at the end, is everything a tank within it? Or maybe there are something else. And if everything is a tank, then good news. I have just proven stability, which is part of what a robust AI can do. And so these kind of processes, this is new ways to validate robustness, which are now prescribed through the standardization to answer the regulation. Another aspect we can explore using this kind of methodology is explainability. So previous speaker also touched a little bit on this topic, but usually AI systems are kind of hard to interpret. It's basically usually seen as black boxes, where you cannot really look inside and understand what it is. We challenge that. We say, no, you can look in it. The only problem is that it's a big mathematical formula that for a human mind, you don't understand. But for a machine can understand that. Machines are dealing with large formula all the time, better than us. So we can use machine and tools in order to open the black box and interpret why the system is telling me that, yeah, these are planes, and I know, and now I want to know exactly for what reasons these are planes. All of which I can use then in my verification scheme, because if I'm telling you, yeah, this is a plane because there is cloud, Well, that's not a good reason for building a plane. A plane is not made of clouds. But in most of my images of plane, I probably have clouds. So maybe there is bias there. So I want to verify the absence of bias using tools in order to verify that my system is recognizing planes for the right reasons. And that's also corresponding to some requirements I could have written before and verified afterwards. So you can see, basically, we have already existing methods in order to evaluate the performance of an AI system. Usually it's statistical methods. They are basically measuring accuracy, recall, F1 score, this kind of stuff. And for data scientists here, I think I'm speaking plainly for you. But for the others that don't know exactly what it is basically you pick and choose some data points within the input space, you verify how much your system works on that, and you made a metric. With formal methods, the one I shown you before, you can explore around it, and you can verify how the behavior is working on more than just data points. You can do it on all subspace now. And so by combining the two, you can explore the input space and verify across it. And so this is what the standards are now prescribing you to do in order to verify robustness. And this is something we actually done in a project, for example, with the EASA. So it is the European Agency for Avionics Safety. And basically they ask us, well, we have written some requirements on our own, like the AI Act, and we would like to verify how much they are applicable in real life. And for that, they tasked us to do real-life verification on systems. So we had these three systems. So one was air traffic speech-to-text, so basically a pilot talking to the control tower, and with all the noises, the accents the pilot can have. Another is an algorithm for collision avoidance. So two planes closing in. What are you going to do using an algorithm to avoid them to crash together? And the final one was visual inspection. So basically, you imagine a drone, hovering around a plane and telling you, well, there is a dent here, there is a lightning strike here, so you have maintenance, plan for the plane, set it up automatically. And so for these three, we use the methodology I described you before, so robustness, explainability, statistical approach, formal approach. We've done all of it in order to see whether or not it was feasible in order to verify the robustness of these applications. And if you're interested, you can type the MLIP project on Google, and all the results are available. It was funded by the EU, so the EU is quite nice with that everything is free for everyone. And so what we had as a conclusion of this project is that there is no one step of validation fits every AI system plan here. Basically, it's an iterative process. There is no way to start from a requirements and end up with a perfect AI in one straight line. So the V-cycle doesn't really work. We can mimic something that look like that, but we have to integrate a lot of feedback loop. We need to integrate the fact that AI are not designed perfectly right away. They are designed through trials and error, basically. But you can orient the way these trials and error are done by using requirements, by using methodology, by using tools. You just have to implement that into your organization. You're not just doing like randomly exploring to find an AI system that works. And so these processes, we also help companies implement them within their organization in order to have like safe release of the AI system into the market. But all of that brings us to a fundamental change in the mindset we need to have. Like, we cannot build AI system without having new processes, new skills, and new tools. Basically, in order to have conformity, you need to change the way you build your system. We've seen it before. The classical way doesn't apply for AI system. It has to be iterative, and it has to do with monitoring in operation, because your domain, since you don't really know what it is at the beginning, probably change at the end. And so you have to monitor all of that in order to include it into your scheme of deployment and validation. And all of it is requiring to have human skills to be developed. There are, I think, new work that will appear in the next years, because right now we are just relying on something called data scientists, and I think we need to grind it down into more specific niche skills area so that we can have like highly competitive and highly skilled workforce in order to challenge all of these, to tackle all of this challenge we have. And finally, we need to have new tools. Basically, the current tools to design AI software are not enough. They are good for training, and nothing for the rest. So we need to have like a more CI/CD, so continuous integration, continuous development approach, in order to have like full control over the life cycle of an AI system, of what it does. And we can rely on that on formal methods in order to verify not just on data points, but also subspace. And there is also a whole deal with hardware, but I'll not delve into that, maybe if you want any questions. And so what we do at Numalis is basically we deploy formal method at scale. So basically we can take an AI system, take a description of the input space you want to validate, and we measure how much the system is robust, how much we can explain what it does. And we do that with a tool called Sample. You can try that for free if you want. There is a freemium version if you want on our website. And all of which is responding to the regulation of the EU AI Act, but probably the others that are brewing, because like I said, everyone is trying to copy on the EU AI Act on how to do it. And everything we do answer the standards I was talking before in order to assess if your system is robust or not. We still have time for a few questions if you have, and thanks for everyone for coming. And if you have questions, please, I say now. Thanks.
Hi, thanks a lot for your talk. I'm very interested on the responsible AI and explainable AI bit. I'm coming from finance, and my question is, like, you showed in the last slide, like, EU AI Act check, right? But there we have this risk-based approach, what is introduced, and the interpretation of what it means to be compliant is like open, let's say. So it is open for non-critical stuff at least, and it's also still open who is going to check your compliance, because you can do the conformity assessment, but it's not clear like who will be the entity to control you in the end. For us, like in banking, we have ECB, national authorities. What is your perspective on this? Who do you think will be in the? Will there be an entity that will control our compliance with AI standards?
So, what I can tell you is that, well, there is the AI office, but I don't think they will do that. But they will try to monitor and try to organize the market for that, I think. What would happen is that if you're in a domain where you already have certification and competent authorities and competent auditors, they will probably inherit for your specific domain the competency to do that. If you don't have that, for example, in HR, you don't have competent authority and certification right now, but you will need some under the AI Act, probably it will end up in the hand of your government to nominate someone. So, for example, in France, the CNIL, so it's the one dealing with all the GDPR stuff, are probably going to inherit this responsibility, whereas for the aeronautic or for the automotive, they are already existing ones, so they're going to delegate to them. So I guess for your kind of business or banking, you will have the same people that you already have now, but with new competencies in order to audit your system.
Thank you.
Thank you, Arnault.
All right, thank you everyone.